Howdy everybody in YouTube land. So we are back on this Sharp TV board that has the no color problem. So I have been kind of tinkering around with this all day today to try to figure out what we got going on, and I've tried where we last left off is swapping some of these ceramic capacitors out with the other board. Nothing wrong there. Tried adjusting the trimmer. Nothing wrong there. I didn't quick dry checks of the resistors. I didn't see anything that I could tell. I'm in the process of figuring out what this chip actually is, and I did find out. I did find out what that chip actually is, and there's an NTE replacement for that chip, which there's also, with the NTE replacement, when you look up the NTE part number, you can actually see what other chips it comes with or replaces, and that's when I found this, the TA7670. Problem is, it's all in Japanese, and this is also all in Japanese, but luckily someone on one of the Discord servers that I visit all the time had translated this for me. So now I have a sheet here that shows what this actually is. So now I've got a better detailed idea of what this chip is physically doing. So we have this chroma input, which that signal's present. All of that's good. We have the chroma output, which we have a burst there, but it has no color information. So we got to get down to the bottom of that. Now, what we also have this killer filter, which is not that important, but we also have this automatic phase control network here, which is what locks the color phase, the burst phase, with the crystal reference frequency. It keeps all of this locked together because this is a VCO, which is a voltage controlled oscillator. At least that's my current understanding on how that works. So this thing is driving me absolutely bonkers. So I'm probing pin 12, but if we look at pin 12, we have, or on this chip here, so pin 12, that's the chroma output. But if we look, we have burst lock right here. So we got the color burst coming in, but we've got no color information going out. So it's like this is being shut off. And the killer circuit is part of this, but I don't know why it's being shut off. It doesn't make sense. Now, if I go back a stage and then go to the chroma input, which I'll show here in a second. Alright, so now I'm on the chroma input, and if we look at that, that signal is present. And this is exactly what it's supposed to be, which is, if we look at it here, right here. See? It's accurate. That's exactly correct. So I got chroma coming in. Now the voltage is a little low. It's supposed to be closer to 0.3, but that doesn't matter because if I drive it with composite input, I get a higher amplitude, but I get the same problem. So I've got chroma going in here, but I got nothing coming out. I get burst lock, but that's it. I got no color information coming out. Why? I just made an interesting observation. So if I take my screwdriver over here and do something stupid, like short out the color gate into the color filter or color killer filter, I can kind of get something to show up a little bit, right? Look at this. Color's trying to come in, but it's running at the wrong frequency. That's a strange one. So maybe that's what it is. Maybe it's running at the wrong frequency. The next thing I'm doing is I'm taking a look at this signal here. So this signal here is automatic phase control filter, which is what adjusts the VCO to keep everything locked on the 3.58 megahertz crystal, right? Well, if you look at it, see this flashing line? It's trying to correct it, but you can see the beat frequency. So the VCO, for some reason, cannot be corrected. And I don't know why yet, but that's just a current observation. It's not able to correct the frequency, so it's running at the wrong frequency. So there's a couple causes. Either A, the circuit is not able to tune itself, or B, we're missing the burst lock is not, I don't know, something's up with that. Watch this. I'm going to take my finger, go right near the oscillator. You see what's happening here? It's adjusting the frequency. So I'm using my finger as the variable frequency control. Now watch this. When I try to bring that in, boom! Fucking works. Now it's locked. It's supposed to be flat. When it's not flat, it means it's trying to correct the frequency, but it can't. So there's a problem in the oscillator that's not allowing it to correct the frequency. As soon as I stick my finger into the frequency control, it locked the signal. There's the problem right there. Booyah. Now, the plot gets even more interesting. So my oscilloscope is connected right here, which is the APC filter network. The automatic phase control, which is the PLL error signal. That's what we were seeing on the scope. And as before, with the scope probe connected there, if I bring my finger near this trimmer capacitor, it'll just work, right? Now, if I remove the scope probe and get rid of it, carefully, get rid of the scope probe, and I do the same thing, I bring my finger near this trimmer cap, it doesn't work. I'm just physically touching it like before. It doesn't work. So, that additional 1 megohm impedance across that APC filter is also contributing to this circuit. So, I'm thinking there's an open resistor or something within that feedback network that keeps the oscillator locked. That's what's going on here. I just have to find it. So before we get too carried away with the oscillator circuit, I went ahead and changed the crystal. So I pulled the old one off. This is the one that was in there. These are like a series crystal versus a parallel. It's a little different. So normal crystals won't work in there. But I took the one off of the other board that does work. So we're going to try that out now. Now I checked all of the supporting resistors here that I could find. They're all good. These diodes are good. All that stuff's good. I checked the APC filter there. That's all fine. So I'm not seeing anything. The frequency is off, and it's too far off for it to lock. Why, I don't know. But we're going to change the crystal because maybe the crystal is just too low. So we'll give that a shot and see what happens. It's just so painful trying to unhook all this, pull it out here, then hook it all back, and then pull it out again, hook it all back, because those wires are too short for this. Now that I got it all wired back in there, let's hope it works this time. Powered on. Let's see. No. Dang it. I'm not entirely certain what is causing that. There's some kind of weird issue with the oscillator. I think me adjusting the oscillator is compensating for a problem that still exists. So let me grab my screwdriver and let's see. Because I changed the crystal, so this might need tweaking. No. No good. It's definitely an interesting scenario. It's weird. I don't know why. Yeah. And it won't lock. It won't lock unless the scope probe is connected either, which is so strange. Like, I have to physically grab this. Grab you there. Oh, that's an issue. So I can't get this board exactly right every time. Grab you. Plug you in there. And then do ground here. And just slowly touch it. Which, I can't remember if that's the point that I was touching before. It may not be. Yeah, no, now I'm not getting anything. Wow. I made it worse by changing the crystal. Anyways, so yeah, that didn't work. What in the world could the problem be? Huh. This one's putting me through the ringer. So this is literally turned into a clown house. Now, what I've done so far is I added a 1 meg resistor to simulate the oscilloscope probe, which is not hooked up anymore. Now, if I take my finger and bring it near this trimmer capacitor again, I get nothing. But as soon as I touch this resistor to ground, it'll come right back. See? But if I let go of the resistor, hold on, let me get the right, it'll fade out. See? Touch it again, it comes back. Let go of the resistor, fades out. It'll run and run and run, and then boom, fades out. So that tells me there's a capacitor charging up or discharging when I hit this resistor to ground. And this is that APC feedback loop. So if I let it touch the ground and let it go, it'll stay running, but then it'll just fade out like that. It's acting like it's acting like there's a capacitor that's being discharged through that resistor and charging up. And where that resistor is right now is here. So I put a resistor right here, and it's a 1 meg ohm that I'm taking to ground. So pin 15 is that APC filter output. So when I ground this through the 1 meg resistor and then change the resistance capacitance of using my finger, what's going on here, it'll lock and it'll work fine. But the minute I let that resistor go, it slowly fades out. So, and obviously I can't scope that because the scope adds a load, So anyways, there's whatever is going on here is completely escaping my mind. But what is obvious is this crystal oscillator circuit is not locking. It is not locking at all. So what I've done is I've checked all of this. I've swapped that crystal out, no difference. Checked that resistor, it's good. Checked these two, it's good. Checked all these diodes and all that stuff's good. So unless one of these capacitors here are leaky, then I don't know what else it could be. I'm literally running out of options. I could be chasing a red herring and there's something else, but the PLL will not lock. It won't phase lock to the color burst, which is what the problem is. So I think what I'm doing is when I'm adjusting the frequency of the crystal circuit manually, acting as like my own self VCO, it locks. But it will only lock if I do something with this APC filter to ground. If I ground that pin, it will lock. But if I let it go, it'll slowly drift itself out of lock. So there's something, and I've been over this board. I'm not finding any broken traces, anything like that. So I don't know. I'm kind of running out of ideas here. Alright, so here's what I've done. I took that 1 meg ohm resistor and just kind of shoved it into this ground hole there. Soldered it onto C806. And then I took a 10 picofarad capacitor and soldered it right on this crystal capacitor into ground. So essentially, what I've done here is there is a cap now from here to ground. And then what we've done is we've taken a resistor from here to ground, 1 meg ohm. And what I'm going to do is I'm going to fiddle with that and see if I can try to narrow down what's going on with the color. So let's get the power turned on. So I'm going to get my finger over here and get ready. Whoa. And now it's working. Now it's working. What in the world am I compensating for by doing that mod? Well, will it stay working? I don't know. I mean, you can clearly see we've got some issues here because we've got chroma lag. But, hold on, let me adjust the fine tuning control. Because it could be that. Well, color fades out, so the killer is working. Yeah, it's working. What? It's working. Just by doing this. So that almost makes me think that, and I've checked all the resistors are fine. That almost makes me think one of these ceramic capacitors is open. And that 10 picofarad cap. Let's think about this for a second. What in the world am I compensating for? So there's a 33 PF here, right? But I'm adding another one from here to ground. So just pretend I just put a 10 picofarad from here to ground. That's it. That's all I'm doing. Minus adding a resistor over here. Now, if I don't put that resistor in, it won't work. So clearly, that cap is fine. It's been replaced. Unless this one's open. No, I checked that. That one's fine. Because remember from the previous video. So I checked that. This is also good. So this circuit's good. I checked the 12 volt supply coming in. It's good. So this is working fine. But adding a resistor from here to ground creates a voltage divider on this line. So it's compensating. It's reducing the error voltage. It's reducing this error voltage down a bit. So I'm compensating for something by doing this mod. But what am I compensating for? That's the question. If anybody could answer that, would be amazing, because I have no idea. But that is interesting. So let this run for a bit and see what happens here. So this thing's been running for a while now, and it seems to be working fine. I got the rabbit ears all hooked up, and I'm transmitting a signal to it on channel 6, and it's working perfectly fine. It's not showing any signs of faults, glitches, failures, anything. So, and then of course I would say that, and then I'd lose color. Oh, no, there it is. Yeah, it's this tuner. Yeah, not surprised. It's the tuner. Because it's been out in the weather. So, anyways, I don't know what the problem is. The modifications I put in is working fine. I'm inclined to leave it. So I'm probably going to tidy that up and just kind of solder them in there properly. And then do it that way. And just leave it alone. The only other thing I can think of is maybe one of the ceramics off of the crystal has gone open or leaky. I'm not sure. I've tested most of the caps out of circuit and they're all fine. So I don't know. But there was some capacitor goo damage on the board. I mean, I cleaned it up, but maybe it's changed the capacitance of the board just slightly enough to throw this circuit out of tune. I don't know. But I did add that capacitor across the crystal there, and I added that resistor on the APC line, and it works. I'm just going to let it run for a while and just see if I get any more problems. And if not, I might wrap this guy up. Because it's not the correct fix, but it's a modification that brought it back. So, I mean, it is what it is. I've already got days and days of time in this TV trying to figure it out. So I think it's good enough. It's working good enough. Sometimes you just got to use a little bit of intuition and just experimentation to figure it out. And it works. Alright, so this thing has been running all night long. Well, just now walked in here. It's 8 o'clock Sunday. And yeah, I've not had any issues. It's working perfectly fine. So let it run all night long. Still has color. And I turned it back off and back on. Everything's fine. So I'm just going to go ahead and unplug the power. Let it cool down. And I'm just going to go ahead and put these parts in here in a more permanent fashion instead of just laying in there. And just call it the bodge of the century. And get it done. Because we need this TV for VCF East 2023 for the show to do the exhibit. So I got to get it fixed so we can get it out to the show and hopefully have a good time. Yeah, so all right, we'll get this board out of here and get it in here. Knowing my luck, I go to do the modification, it's gonna not work, but it'll be fine. I have the bodges now moved to the bottom of the board just to try to hide them, and they're less obtrusive. Plus, they can be removed if, for some miracle, the actual problem is discovered. But in the meantime, they're now connected in circuit. So I'm just adding 10 PF to ground with the crystal network, and then this doesn't work unless that's there. I don't know why that is, but I swear, sometimes I think... So, I'm editing this video, and I wanted to add some cliff notes in here. It's been a few months since this, and this board had some pretty bad capacitor leakage in this area, and it was recapped by the owner, right? So, I'm starting to wonder, even though the board was cleaned up, I'm starting to wonder what happened was the cap goo got into the board, and it altered the characteristics parasitically just enough to throw this circuit out of tune. It's the only conclusion we were able to draw, and this circuit here is overcompensating, or bringing the circuit back into tune to overcompensate from the added capacitance of this phenolic being soaked with capacitor fluid internally, right? It's the only conclusion that I can draw, and it's the only thing we came up with. Also, it's extremely sensitive to the input on the tuner, because once the owner got it back, if the input on the tuner is weak even a little bit, it drops the color. It's got to be stronger than average in order for it to come in. So there's still an issue there, and we never got to the bottom of it. But if the signal is good enough, it does have color, and it will maintain color. These TVs just work off of prayers and wishes, because yeah, shield's back on. So hopefully when I put this back together, I still have color now that the lead length has been reduced and we're now on the bottom, because that could even play with it. And then, as I was demonstrating earlier, now that I got the board out of the way, it's easier to see. When I was touching this with my finger, see, the thing is, what your finger do is your finger acts as a parasitic capacitance, resistance, inductance, and all of that. So when you put your finger in here, you're introducing those parasitics into the circuit, and it's a good troubleshooting aid to figure out, okay, what am I compensating for? I'm compensating for a change of capacitance. I'm compensating for a change of resistance, things like that. And obviously, you don't want to go poking in a high voltage circuit, so please exercise caution when you do this. But I know all this section here is all low voltage, so I can get away with doing that. Alright, so the modification's complete, and I still have color. And on the top, you can't tell that it's been modified because it's on the bottom. So I think I'm going to call this a win, and I'm going to leave the video off here. It may not be the right fix, but it's a fix, and it's going to do the job, and it seems to be stable. So I'm going to leave that as that, and everything should be fine from here on forward. So anyways, if you have a comment, please feel free to leave one, and don't forget to hit the like and subscribe, and you know, all of that fun stuff. It really helps the algorithm, and it helps me get views. So thank you for watching, and until next time.